from today's round, Codeforces round 781, Div 2C. The solution is as follows. So we've been given a tree where, okay, you can read the problem statement. The way we solve this is via two observations. The first observation is that uh, only siblings affect each other because the way the problem has been set up, it says that spreading can only happen from from a sibling to sibling. So it doesn't matter. So let's say this is the tree. Okay. So if this was infected, now only in the next time period, only this and this can be infected via spreading. All the other nodes won't even know that initially this node was infected. So yeah, this is the observation number one. Uh, and observation two is that it is always beneficial to uh, choose the set of siblings which have the most number of nodes in them. So, for example, if this was our initial tree, we would have liked to choose one of these five vertices because if we had chosen this initially, while once we've chosen this, then we move on to on to choose the vertices from the next set of uh, vertices, the next set of siblings, and while we are visiting the other sets, this set, the siblings in this sets would be infected via spreading. So that would be taken care of. This is intuitive. Greedy strategy is intuitive. Okay, so once this is done, so the way the input is defined is this means that one is the parent of node 2, one is the parent of node 3, one is the parent of node 4, 2 is the parent of node 5, 2 is the parent of node 6, 4 is the parent of node 7. So this makes it easy for us to group siblings. That is, all the nodes with the same value form a group of siblings. So yeah, so this was the input. We can say that we've been given three groups of siblings, and if we talk about the sizes, these are the sizes of the three groups of siblings. If we consider a general case of the same, we can say that if we have n groups of siblings, we'll first sort according to observation 2. We need to first sort the array in decreasing order. So a1 is greater than a2 is greater than a3, greater than equal to. Right. Okay, so once this is done, we ask the question that given time x, can the tree be infected in less than or equal to x time? If you're able to answer this query efficiently, we can do a binary search on time x. Yeah. So, okay. So first of all, let's consider the case when only one element from each set is infected, and and we're not right now. We're not considering the case when multiple siblings can be infected. So we are considering that only one node of a set of siblings would be infected, and the rest of the siblings would be infected via spreading. Okay, so if this is the case, uh, if we have considered this to be the set, the vector of set sizes, uh, in the reverse sorted manner, we see that for all i's, for all ai's, this set would be in one node from this set would be infected at time t is equal to 1. One node from this set would be infected at time t is equal to 2, so on, and this one node from this set would be infected at time t is equal to n. So what we want is that, and we see that if there are I number of nodes, uh, then the last node would be infected at time I plus ai minus 1. So if for all I this time is less than or equal to x, then yes, obviously, given x, the tree can be infected in less than or equal to x time. If this is not the case, however, we need to consider the case when we're allowed to infect multiple siblings via direct infection. So the way we do that is first, uh, for at time t is equal to one node from this would be infected, time t is equal to 2, and at time t is equal to n, one sibling from this set of siblings would be infected, and then we are allowed to infect the leftover nodes from the n sets also. So at time t is equal to n, the number of nodes left is summation over all I, uh, summation over all I, this quantity, that is maximum of, if this says the number of uh, nodes left uh, in set I at okay, this is number of loads left after time plus 1, number of loads left given time x. Okay, so after time n, that is after this instant of time, the number of nodes left in the ith set would be I plus, so let's, I plus ai minus 1 is the um, this is the number of uh, the, I plus, this is the time at which the time required for the nodes to be exhausted, while x is the time given in the question. So these number of nodes would be left, if this is a positive quantity, these number of nodes would be left from set I, and the total number of nodes would be summation of overall all sets, all I. So if the number of left nodes, if the number of nodes left is less than or equal to x minus n, that is the time left, because at each uh, time instant we can delete, we can infect one node. So if the number of nodes left is less than or equal to the number of times left, that is x minus n, we say that yes, this is, it is, the tree can be infected less than or equal to x time, else no. The code is uh, basically what I just explained. Um this is the A array we were maintaining, and this is the code for binary search. Func is the function, is this function. It basically poses the question that how many nodes are left. Uh, yeah. So if for set I, the time required to delete to infect whole of set I via only direct infection is greater than x, then the number of nodes from set I left at time t is equal to n is given by this quantity, and we add this over all the sets. If the number of left nodes is greater than x minus size, we return 0, else we return 1.